Welcome to MRL. In this learning session, today's learning session, we'll be learning about factors and multiples. So let us begin. Of course, some of the other important properties of numbers we'll be learning in this learning session. Now, what are factors? Now, if you take a number 24, the factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 14. Now, 1 divides 24 completely, 2 divides 24 completely, 3 divides 24 completely, 4 divides 24 completely, 6 divides 24 completely, 8 divides 24 completely, 12 divides 24 and 24 also divides 24. So a number which divides another number exactly or completely is a factor of the number. And if you observe here, the 24 has got countable factors, and therefore the factors of a number are always finite. 1 and 24. 1 is a factor of 24. 24 is also a factor of 24, but we call them as improper factors. Rest of them are proper factors. 1 is a factor of every number. You take any number, 1 is always a factor of it. And every number is a factor of itself. If you observe here, 24 is a factor of 24, and therefore every number is a factor of itself. And every number has at least 2 factors except 1. 1 has only 1 factor, leaving 1, rest all of them have at least 2 factors. Now, having understood what are factors, let us understand what are prime numbers. Now, the numbers which have only 2 factors are called as prime numbers. For example, the factors of 2 are 1 and 2, only 2 factors. Factors of 3 are 1 and 3, only 2 factors. 5, 1 and 5, only 2 factors. So all those numbers which have only 2 factors are called as prime numbers. So therefore 2, 3, 5, 7, they're all prime numbers, and so on. We have innumerable prime numbers. The number which have more than 2 factors are called as composite numbers. For example, the factors of 4 are 1, 2 and 4. Factors of 6 are 1, 2 and 3 and 6, 1, 2, 3 and 6, and therefore there are more than 2 factors. Therefore 4 and 6 are composite numbers and not prime numbers. So the numbers which have more than 2 factors are composite numbers. The numbers which have only 2 factors are called as prime numbers. Remember that. Now, proceeding further, let us talk about 1. Now, if you observe 1 has only 1 factor, and that is 1 itself. So 1 is neither a prime number nor a composite number. 1 has 1 factor, it does not have 2 factors, therefore it is not a prime number. It has got only 2 factor, it has got only 1 factor, therefore it is not a composite number. And therefore, then what is 1 then? 1 is a unique number. Therefore we call 1 as a unique number because it has only 1 factor. It is neither composite nor a prime number. Now, what are twin prime numbers? Now, if you take 3 and 5, now 3 and 5 are definitely prime numbers. 3 and 5 are prime numbers, but the difference between 5 and 3 is 2. The difference between 3 and 5 is 2. Therefore, 3 and 5 are called as twin prime numbers. So, 2 numbers which are prime numbers and the difference is 2 are called as twin prime numbers. For example, 5 and 7. They are prime numbers, the difference is 2. 11 and 13, they are prime numbers, the difference is 2. Therefore, they are all twin prime numbers. Now, prime factorization. Expressing a number as a product of only prime numbers is called prime factorization. What does this mean? Let us take, for example, 12. 12 can be divided by 2. 2 is the smallest prime number. 2 6 are 12, again by 2, 2 3 are 6, 2 is 2, and therefore we get the 12 as a product of 2 into 2 and 3. 2 into 2 into 3. Here it should be 3, not 2. Therefore 2 6 are 12, 2 3 are 6, 3 1 are 3. Therefore the prime numbers are 2, 2 and 3. Therefore the prime factorization of 12 is 2 into 2 into 3. Now let us take 72. The prime numbers of 72 are the product of 2 into 2 into 2 into 3 into 3 gives us 72, and therefore these are prime factors of or prime numbers of 72, and the process is called as prime factorization. Please remember, the prime factorization of any number is unique. That means this prime factorization cannot be for any other number other than 12. This prime factorization cannot be for any other number other than 72. Now remember, the division method of finding prime factors is what is followed here. So therefore, to find prime factors of a given number, we have to go for a division method. The procedure is followed, what is given here, and the prime factorization is a process of expressing a number as a product of only prime numbers, and that is what you have to remember. Now let us talk about multiples. 2 to the 4, 2 to the 6, 2 to the 8, 2 to 5 to the 10, 2 to 6, 12, 2 7, 14, 2 8, 16, and so on. They are all multiples of 2. And 3 1s are 3, 3 to the 6, 3 to the 9, 3 4 12, 3 5 15, and so on. They are all multiples of 3. So multiples of a number are repeated additions of the number. Every number has infinite multiples. Remember, every number has infinite multiples. And when we talk about repeated addition, see, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, and so on. So therefore, first of all, multiplication is repeated addition. Here we are adding 2 for every number. So 2 plus 2 is 4, 4 plus 2 is 6. They are multiples of 2, and remember that. And the multiples of any number are infinite. Even numbers. The numbers that are multiples of 2 are even numbers. For example, 2, 4, 6, 8, 10 are multiples of 2, therefore they are even numbers. And also the numbers with unit digit as 0, 2, 8, and so on, they are all even numbers. That means if the digit in the units place is a multiple of 2, 100% that number is an even number. Odd numbers. The numbers that are not multiples of 2 are odd numbers. For example, 1, 3, 5, 7, 9 are not multiples of 2. They are not divisible by 2. They are odd numbers. Numbers with units digit as 1, 3, 5, 7, etc. They are all odd numbers. So please remember this. That means how to identify even numbers and odd numbers is very, very simple. Now perfect number. Let us consider a number 28. Now the factors of 28 are 1, 2, 4, 7, 14, 28, because 1 divides 28 completely, 2 divides 28 completely, 4 divides 28 completely, 7 divides 28 completely, 14 divides 28, 28 divides 28, and therefore these are the factors of 28. But when we add these factors, please add 1 plus 2 plus 4 plus 7 plus 14 plus 28. When we add, we get 56, and 56 is twice 28 or double of 28. So therefore 28 is a perfect number. That means a number, the sum of factors of which the addition of the factors of 28 is double 28, double the number 28, and therefore 28 is a perfect number. Therefore, if the sum of the factors of a number is equal to 2 times the number, then the number is a perfect number. So that is what is a perfect number. So 28 is a perfect number because the sum of the factors of 28 is twice 28 or double the 28. Okay, so remember that, or 2 times the 2 times 28, and therefore it is a perfect number. So like that we can find other perfect numbers also. Highest common factor. Now what is this highest common factor or greatest common divisor? So let us understand with an example. Now first of all, let us write the 63. The factors of 63 are 1, 3, 7, 9, 21 and 63. So these are the factors. We know already now what are factors. The factors of 84 are 1, 2, 3, 4, 6, 7, 12, 14, 21, 42 and 84. Now if you observe here, 1 is common to both the number, the factor 1 is common to 63 and 84, factor 3 is common to both, then 7 is common, and so on. But you find the highest common factor is 21. See, 21 and 21 is the highest factor, and therefore the highest common factor of 63 and 84 is 21. And therefore we call it as the highest common factor or the greatest common divisor. So to find the highest common factor, write the factors of the numbers and find out which is the highest common factor, and that will be the HCF or the GCD of the numbers. So please remember, and this also can be taken as a method of finding out the HCF of given numbers. Now there are different methods of finding HCF. We have got the factors method, which you have just learnt. Then we have got the prime factorization method, the short division method and the long division method. Now the prime factorization method, I am repeating it here again to understand it more clearly. 63, factors of 63 are 337. The factors of 84, 2237. Now the 3 is common here and 7 is common here. So 3 is common and 7 is common. Please understand here very carefully. 3 is common and 7 is common. Okay, so therefore I have to multiply, take 3 and 7, multiply it, so I'll get 21. So 21 is the HCF of 63 and 84. So very simple method. Write the prime factors of the number, write the prime factors of the other number, find out which are the common factors in them, and take a product of that. That will be the HCF, and that is the prime factorization method. Now the short division method is again a very simple method which we have been learning from lower classes. Now HCF of 63 and 84, again I have taken the same number here. So divide 63 and 84 by a common factor 3. So 321 is 63, 328 is 84, again by a common factor 7, 7 3 is 21, 7 4 is 28, and you find 3 and 4 are two different factors. Therefore we have to stop it here and multiply 7 into 3, and that will be 21. So the procedure is divide the number by prime numbers. So divide the number by prime numbers, soft division when the remainder have no common factors. Find the product of the divisors. It will be so 3 into 7 is 21, and the HCF of 63 and 84 is 21, and that is the procedure for short division method of finding HCF. A very simple method which you can remember. Now the long division method, this is very interesting here. Now we have 63 and 84. 84 is greater than 63. So divide 84 by 63 first. 63 1 is 63. The remainder is 4 minus 3 is 1. 8 minus 6 is 2. Now 21 is smaller than 63. Divide 63 by 21. 21 3 is 63. The remainder is 0. As soon as the remainder comes 0, then the previous divisor is the HCF, and therefore HCF of 84 and 63 is 21 here. So the procedure I have explained it, try to remember that, and that is the procedure of finding HCF by long division method. Now what is the LCM, the least common multiple? Now what is the meaning of LCM or least common multiple? Let us understand this with the help of an example. Now I have taken three numbers here, 5, 6 and 3. The multiples of 5 are 5, 1 is a 5, 5 is a 10, 5 is a 15, and so on, and it continues because there are infinite multiples here. The multiples of 6 are 6, 12, 18, 24, 30, 36, 42, and so on, and the multiples of 3 are 3, 6, 9, 12, 15, 18, and so on. And if you observe here, the least common multiple of 5, 6, 3 is 30, 30, and 30, and therefore the LCM of 5, 6, 3 is 30. See, please observe here, 5, 6, 3 are different, 10, 12, 6 is different, 15, 18, 9 is different, 20, 24, 12 is different, 25 is different, but here 30, 30 and 30 are common to all 5, 6, 3. They are the multiples of 5, 6, 3, and therefore the least means the least common multiple of 5, 6, 3 is 30. Therefore LCM of 3, 5, 6 is 30. Remember that. Now there are different methods of finding LCM. This is one method, that is directly writing the multiples and finding out the least common multiple, and we have the three methods here, that is direct multiples method, which we already learned here. Then we have got the prime factorization method and the division method. So let us understand the few examples here. LCM of 48 and 56 if we have to find by prime factorization method. Let us write the prime factors of 48, that is prime factors of 48 are 2 into 2 into 2 into 2 into 3, that we get by division by dividing 48 by the prime factors here, and prime factors of 56 are 2 into 2 into 2 into 7. Now what we have to do here, take the common prime factors 2, 2, 2, that means 3 2's are common here. Then remaining also you have to take, that is 2, 3, 7 are not common, but we have to multiply. So take the common factors and again multiply the remaining factors, that is 2 into 2 into 2 into 2 into 3 into 7. When we multiply, we get 336. So 336 is the LCM of 48 and 56. Remember that. Now coming to the division method. There is another method of finding LCM. To find LCM of 48 and 56, start dividing 48 and 56 by prime factors. 2 24 the 58, 48, 2 28 the 56, 2 12 the 24, 2 14 the 28, 2 6 the 12, 2 7 the 14, 2 3 the 6, 2 then 7 remains as it is. Again continue. Now further 3 1 the 3, then 7 remains, 7 1 the 7. So keep dividing by prime factors until you get 1 1 as the remainder. 1 1 is the remainder. Divide by prime numbers until we get remainder as 1. And then after that multiply this 2 into 2 into 2 into 2 into 3 into 7. We get what is called as the LCM of the two numbers 40 and 56. This is the method we generally follow, but otherwise this method, that is the prime factorization method and the division method, are two unique methods used for finding LCM. So please remember that. Now the next very important topic of our discussion are what are coprimes. Very interesting. Okay, let us learn this. Now if you observe 15 and 26, the factors of 15 are 1, 3, 5 and 15. The factors of 26 are 1, 2, 13 and 26. Now if you observe here, the common factor between 15 and 26 is only 1. No other common factor is there, and the 15 and 26 are coprimes. Therefore, the numbers which have the highest common factor as 1 are called as coprime numbers. So 15 and 26 are coprimes because the common factor between 15 and 26 is 1. Please remember that. Okay, or we can even say if the HCF of two numbers is 1, then they are coprimes. Now, relation between numbers are HCF and LCM. If A and B are two numbers, H and L are their HCF and LCM, then the product of numbers is equal to product of their HCF and LCM. That is, A into B is equal to H into L. A into B is equal to H into L. A very, very important relation which helps us in calculations to find LCM or HCF when the product of the numbers and one of the values H or L is given to us. Now, let us take an example. If A is 60, B is 90, then A into B is equal to 5400. Now, let us find the LCM of 60 and 90. The LCM of 60 and 90 prime factors of 60. The prime factors of 60 is 2 into 2, 3, 5. 90 is 2 into 3 into 3 into 5. So, the common factors are 2 is common, then 3 is common, 5 is common. So 2, 3, 5 is common, and the remaining 2, 3, 5 is common, and the remaining is 2 and 3. Okay, take them and multiply. So 2 into 2, 2 into 2 into 3 into 3 into 3 into 3 into 5. So when we multiply, we get 180. Whereas the HCF is only take the common factors. 2 is common, 3 is common, and 5 is common. Therefore, the LCM is HCF is 30. So we have got LCM as 180, HCF as 30. When we multiply LCM and HCF, that is we get H into L is equal to 180 into 30, that is 5400. So we find that A into B is 5400, H into L is 5400. Therefore, A into B is equal to H into L, or the product of the numbers is equal to the product of the HCF and LCM. A very important relation which can be used to find one unknown quantity in this. So remember the relation, very important relation for us to remember. So that was the study for us as far as the subject is concerned. So try to remember whatever I have discussed, what I have spoken to you, whatever given in the written form. Try to understand, repeatedly go through the written material given to you, and also listen to what I have spoken to you, and take a book and scribble and note down the fundamentals or the basics or the properties of the numbers, which is very useful for your future use. Thank you.